Vanakkam, Namaste, Namaskar. Today I'm going to do a small topic on chart work principles only. This is called Beam and CPA. Both these titles, if you see, is very commonly used in all problems, questions, exam questions. But at the same time, if you realize, I think both of them are encountered by you every day. It can be related to a moving vessel, a target, or it could be a stationary target also. It could be a lighthouse, a buoy. A lot of references are made with this two titles, the beam and the CPA. One of them is based on your vessel's orientation. The second one is based on the position. So let us quickly have a look on how we can deal problems for MMD questions, as well as how you deal with it in day-to-day life also. If you ask me, CPA and beam actually come to you every day on the road as well. So I'm going to use a little bit of analogy on the road also for this. I'll try to keep this short because I want to make it to two parts. If I keep it in a single part, it'll be a little bit bigger video. So I'm just trying to make it slightly smaller and so that I can hold your attention. So let us start off this topic as I've clearly mentioned on the title, Beam and CPA. So we will see how we can relate this on board, how we can relate this on the road, and then how we can relate this in your numericals also. Okay, let us look at this beam or a beam. One thing you should have realized when you've been seeing all the questions, the two prominent method of solving a chart work triangle is basically the allowing and counteracting method. And the moment I have this allowing and counteracting method, which means that I have some forces, natural forces. And once I draw a triangle, you have always encountered two courses. So those two different courses are your CTS and CMG, course to steer or course steered, and course made good or course to make good, just present and future. Now, both these courses are different. You'll have to be careful in dealing with them when we talk about the concept which you're going to talk today, like your beam and CPA. Now, there's one more thing you should be careful about, because a lot of beginners and sometimes students who have already been sailing also do silly mistakes on this. They have a doubt, which one should I take as beam, which one should I take as CPA. It's pretty simple. If you can understand the logic behind it, I think you will not do this mistake. But the problem is people are doing the mistake. Now, you already know what is your fore and aft line, or what you call as your heading. We have been discussing about this quite some time. Now, the fore and aft line and heading is also called your CTS, course steered or course to steer. And the moment you know the CTS, the word beam or abeam is always perpendicular to the CTS. That means perpendicular to your fore and aft line and your heading. Please do not get confused with CMG. So beam is always perpendicular to the CTS. I'm going to show you in picture. I'm going to show you with examples. So please hold on. You will get a better understanding. Okay. This is just a gist of it. Let us say the vessel is sailing with a fore and aft line like this. I have an accommodation, then the bridge wing. So if you look at it, this is your starboard beam. And the opposite side is your port beam. Now I'm going to change the orientation of the vessel. See, I've changed the orientation of the vessel. Again, bridge wing. This is again your starboard beam, and this is again your port beam. So if you realize, the starboard and port beam keep changing with your heading or your orientation. Okay. Relatively, they are constant. But when you try to use true readings, they will be changing. So please remember, we have done true boxing and relative boxing. So you need to get a little bit of idea from there. Relative means always your trying to correlate with your fore and aft line. So relatively, they are constant. But in true sense, they will change. So I'm going to give you some examples there also. Right now, I've given you a relative concept. Okay. Now let us come to the CPA concept. The full form of CPA is closest point of approach. The idea is closest. It is directly related to your position actually, and you should not get confused with a beam. There are some exceptions. I'll be giving you examples of exceptions. Let us see what is that. But your CPA, the word closest point of approach, clearly means that he's talking about position. He's trying to relate your position and one more target's position, or it could be a fixed object also. It could be a lighthouse, buoy, anything else, a land, a jetty, whatever it is. So CPA is directly related to the position. And when we are doing our chart work triangle, when I started giving you forces like current and wind and all, I kept on telling you one thing is very important, that the position of the vessel will always be found only on the CMG track, in no other track, only on the CMG track. So now looking at these two sentences, you should realize that CPA is directly related to the CMG, which means CPA is perpendicular to the CMG. Why perpendicular? Because if I give you two objects, let us say they have some orientation or whatever way, they are stopped also, the closest distance is always a perpendicular distance. If I give you two lines, two parallel lines or whatever it is, the closest distance is a perpendicular distance. So CPA is your perpendicular distance to CMG. Please remember this. We'll clarify this with pictures. There is an exception. Let us say I don't have current and I don't have wind. That means there is no environment. That is the only case where your CTS becomes equal to CMG, which means my CPA and beam are exactly the same. So we'll be seeing this example first, and then we'll look at others. So CPA is equal to beam only in a case where there is no current, no wind, because CTS and CMG are same, and both the perpendiculars are also same. Now, why I need to know all this? Because in numericals, they may ask you the position of the beam, the time when you go abeam, the bearing at that particular moment when you are abeam to any object, the range between you and him when you are beam. And exactly the same four titles, position, time, bearing, and range, can be asked for CPA also, because CPA is also a very important issue. How close are you approaching a vessel? It's very, very important for you in day-to-day life. As I said, doesn't matter on the sea. It is valid to you on the road also. Okay, the CPA. We'll understand better with examples. So let us quickly do some examples. Before I want to go to the ship, I want to go to the road. As I said many times that most of the concept what you see on board at sea are there on your day-to-day life also, and you should try to correlate it if you want to understand better and not do silly mistakes in your numericals. So I'm going to talk about three concepts here. Number one, what is beam? I'll be talking about something called right ahead, which can be directly related to right astern also. It's okay, it's just 180-degree opposite. And then CPA. Let us look at this. Assuming that I have a road and I have a man who intends to cross the road in that zebra crossing which I've shown you. So he is facing like this. So he wants to cross the road. Obviously, he will try to take the shortest distance by common sense. And in this road, cars are coming. So you can see cars are traveling from this man's left side and they go to the right side. So I've shown you three positions of the car. Let me call them A, B, and C. These are the three positions a car has crossed this man. The first thing, let us see. Where is the car nearest to you? The word nearest is also called as closest. The word closest, I told you, is related to the position. So obviously, the two positions between the man and the car is closest only at Bravo. So that is why Bravo is called the CPA, which is the nearest distance or the closest point of approach. So this is the first principle, which is very easy to understand. How closest is the target? Again, we have something else here. So I'm going to mark that CPA. CPA is also a distance also. It can have other variations of time and all those things. But right now, if anyone asks you what is CPA, is basically the first thing he's asking you is the distance. So this is the distance between you and him. Now, at the same place, I have something else also. CPA was related to the position, but now I want to look at the orientation of this man relating to the car. So how is he seeing the car? Actually, he's seeing the car right ahead. So this man is seeing the car right ahead. Similarly, you can have the same situation on board also. You can have a situation where that object is closest also and as well as right ahead also. Okay, I'm marking this right ahead. So in this particular case, CPA and right ahead are same. So this kind of situation you can encounter on board as well. Okay. As I mentioned, CPA is related to the position and your right ahead related to your heading or your orientation. Let us change this scenario to understand the next concept. I'm going to change the scenario. Cars are exactly the same. The road is same, but the man this time is not planning to cross the road. He's planning to walk along the direction in which the cars are passing. He's going to walk along the direction. So please try to imagine the man is walking in the direction of or facing the direction of the arrow what I've shown you. Again, let us see what all situation comes. Where is the car closest to you? Closest is position. So man is here, the car is there. So obviously, again, it is same Bravo. Bravo is the nearest distance. Now, something has changed now because your orientation has changed. A vessel also can change its orientation. So let us see what is the change here. How is this man seeing the car? Please remember, now he is not seeing it right ahead, but he's seeing on his port beam. Okay, this is what is called a beam on the port side also. So in this particular case, CPA and a beam are same. I feel this, I think even a non-seafarer also can understand what I've given you. But now let us try to borrow this concept and put it at sea as well. So let us quickly go to the next slide. So please remember, beam means either on the port side or starboard side. When that object of interest, which could be another vessel, it could be lighthouse, is exactly 90 degree to your fore and aft line, which is your CTS. And this is why I said beam is always perpendicular to your CTS. So plus or minus 90. Usually we call this on board as in line with our bridge wings. I'm going to show you a picture of bridge wings also, just for you to understand. Before that, let us look this beam concept in true sense. The last time I showed you this, it was in relative sense. I told you relatively, they're always 90 degree plus or minus to fore and aft line. But let us see in true sense. True sense means I'm going to give you some values of true. Let us say I'm sailing 090. This is my CTS, true. Obviously, in this case, my port beam is going to be true north. Starboard beam is true south. Okay, they are 90 degrees to each other from your fore and aft line. Now, let us change the vessel's heading orientation. If I change the vessel's orientation to 130, please remember, I have changed the vessel's orientation. Relatively, they are exactly 90 degrees away. But in the true sense, please see the reading changes. Now, this is what you need to understand. What is relative and what is true as far as beam is concerned. Relatively, they are always 90 degrees. True, please check your heading and then calculate. You will be needing this calculation because your questions, every question will be with a different heading. And again, heading can be two different, your course can be two different things, CTS and CMG also. So please be aware of this. Just for the sake of beginners and those people who have difficulty in grasping, like pre-C boys and DNS boys, please see here, these are the bridge wings of a vessel. So when a navigator stands on that, we always consider that when a vessel or an object comes in line with our bridge wings, they are called a beam. This is how you will be reporting, and taking your actions also. Okay, that is how it works. Now, before finishing this module, I'm going to take a quick example of beam concept in a real sense, like a numerical. And I will not be putting any forces here. I'll put the forces in the next module, which will come soon. So let us look at this one simple question where I'm not going to give you any forces. So let us look at the basic idea of beam and CPA. Let us say that somebody has given me a fix at 8 o'clock with some method, doesn't matter. He says that from this fix, I have to pass a lighthouse Yankee 3 nautical miles off on my port side. So the lighthouse should be 3 nautical miles off on my port side. That means you should not go any closer than 3 nautical miles. He's asking you, find the course to steer to make this happen. And please tell me what is CPA, what is beam with the lighthouse. So lighthouse Yankee. I'm not giving any environment because this is a basic structure. I want to show you that. In this question, it is possible he can ask you more, as I've already mentioned, beam position, range, bearing, and time. Similarly, CPA position, range, bearing, and time. It is possible he can ask you. You should be ready for that. Now, the same question, let us try to look at how to solve this. Let us say the initial fix was given with a lighthouse X, some bearing, some distance, and normal fix. So this is my 8 o'clock fix. And I have a lighthouse Yankee, which is somewhere here. Intention is to go clear of this Yankee 3 nautical miles and keep the Yankee on my port side. So whenever he says that pass some miles off, your first job should be that you should never go closer than 3 nautical miles. So I'm going to draw a circle of 3 nautical miles with that Yankee. My job is never to enter that circle. So what can I do? I have a choice. I can draw tangent. So that means from my initial position, I can draw a tangent. Please remember, if my vessel is on this line which I've just drawn, you will realize that I'll keep the Yankee on my port side. So how will you travel? It's pretty easy. This is your course to steer. Let us say it is 080 for an example. So my vessel is also going to steer 080. This is the CTS. So I already found the CTS by drawing the tangent. I'll keep going like this. Now I have two jobs. I need to find what is beam and what is CPA. Please remember, CPA is always based on position. So he's asking you, where will you be the closest with the lighthouse? It's very, very evident on this diagram that my tangent point, exactly where my course line is skimming the circle, tangent point is going to be my closest point of approach. And you will see that closest point of approach is going to be my beam position also, because in this question, I have not given you current and wind. So in this typical example where no environment is there, your CPA position and beam position have to be same. The course in which you are traveling, where your position is, if you draw a 90-degree to that, that is what is called CPA. But at the same time, you have a fore and aft line. You draw a 90-degree to the fore and aft line, then that is called beam. And both of them are exactly same here. So this is one of the easiest simple example to compare beam and CPA, and with no position. Now I can give you a question. Instead of telling you pass 3 miles off and keep the lighthouse on the port side, I can do the opposite. That means I can tell you pass 3 miles off and keep the lighthouse on the starboard. So obviously I'll be traveling in a slightly different way, and I'll be going like this. Now, one thing you should realize, the last sentence which I've written on the bottom, since CP and beam position are same, there's no change. So your beam range, time, bearing is going to be exactly same as CPA range, time, and bearing. So this comes to an end for this particular module, where I've just given you the basic concepts of what is beam and what is CPA. And I'm going to make a second module, which will come as part 2, will be coming soon. So I'm going to show you there. I'm going to continue from where I'm leaving. I'm going to use environmental forces. Then I'm going to show you a second case of beam also. There's a different case of beam that can come in a question. So how differently the questions can be worded, that is what I'm going to do. Hope the beam and CPA is clear for you, and this can make you avoid your mistakes in the numericals as well. Anyway, till I catch you next time, it's Vanakkam, Namaste, Namaskar from me, and keep watching Jal Prayag. I'll catch you soon.